Et donc nous allons poursuivre sur le sujet.
So we're moving on the same topic by �𝗀𝗲𝗬 𝗀𝗃 from the iteipmai, and she's going to tell us about the metabolic and physiological response of MAP plants. She joined us in 2022 for an internship, and then she started working in a university branch, and then came back to us as an experimental officer. Now you're doing a thesis in 𝗀𝗀𝗃 project, a project that the iteipmai is leading in the southeast of France. It is a project that you have also co-designed and co-written. So now you're doing a thesis with the INRAE in Clermont-Ferrand, and you're working on the impact of shading on maps. So you have the floor to tell us all about it.
Donc moi, je vais vous présenter les réponses.
I'm going to talk to you about the response of maps to shading in the Mediterranean region. As Bruno said, I am doing a thesis within the INRAE of Clermont-Ferrand and together with the iteipmai. The map sector in France, 350 species, 120 of them being grown, and most of them are used for essential oils and other extracts, 90%, and 10% are used for aromatic purposes that can be used in perfume, food, medicine, and so on. The specificity of the map sector is the diversity. We have a diversity of cycle, perennial or not, the ecology, south, north, and so on, the part of the plant that we are using, and the component that we are looking for in the plant. Within our studies, we chose 3 model plants. The hybrid lavender, which is a perfume plant, perennial plant, used for its flower for essential oil, and which is heliophyte, which means it loves the sun, and xerophile as well. We also used curly parsley. It's a year cycle plant. It's a mesophilic plant. It loves damp soils. And valerian is a medicinal plant. It's grown either on a yearly rotation or bi-yearly rotation. It is used for medicinal purposes with extracts, and it loves shady environments with water. Our sector, just like any other sector, has many challenges to face. Climate change, of course, the increase in temperature, and the increased frequency and intensity of heat waves, and also a change in the distribution of precipitations. Less rain, but stronger rainfalls. And the current climate in the Mediterranean Sea is going to move north. So we chose plants that are grown all around France to know if the current weather climate we have in the Mediterranean region will actually be the one that we observe in the decades to come in the north of France also. So agroforestry is actually one of the solutions for this climate change, because it's a resilient system. As was said in the previous presentations, there's a lot of interaction between the crop and the trees. And so we decided to focus exclusively on the impact of shade brought on by the trees. Our experimental method. We set nets as if it was a tree hedge. to bring shade to the cultures, to the crops. And we studied the impact of shade on the microclimate and the plant under it. Our experimental plot is in the south of France, in the Mediterranean climate area. You can see a picture of our experimental plot. It was designed so that the shade is brought to the plant at the hottest times of day. On the left, we have the curly parsley with shade. And after the 15 meters, we also have 15 meters of valerian. 4 meters further, without any shade, there's the control parsley and the control valerian. Then we have the control hybrid lavender. And then we have 2 rows of lavender with nets, one with a black net, one with a green net. We were supposed to have 2 intensities of different shading, and we actually realized with the measurements that the same level of shade, but the red rays were different. So it's still a difference, but the more specific level. For the hybrid level, we have 3 lines: the control, the black net, and the green net. For the parsley, we had 2 different studies with control and black net, but we changed the distance to the net. We have rank 3, line 3, line B, line C. And we also had 2 modalities for the valerian, the control and the black net. And we had a lot of captors, dendrometers, at the basis of plants to measure the variation of diameter in the stalks. A lot of sensors to measure the microclimate: light, temperature, humidity, wind, etc. And all these captors are connected to an acquisition station with every minute there's a measurement taken, and the average is calculated every 30 minutes. In the measured plot, we have the quality of plant, the yield of plant, the growth of plants. And we also made some measurements about the hydric situation of each plant. We tested the hydric potential of each plant. We tested the photochemical efficiency for photosynthesis. Now, the results. This is an example of a curve that we got from the dendrometer that we placed on stock for the hybrid lavender. The dormancy period during the winter first, and then you can see a phase of increase of the plant, so an increase of the diameter of the stalk. Then the flowering part, there's a small reduction of the diameter of the stalk. We harvested the flowers, and then there's a heat wave period. And you can see that the maximum diameter, daily diameter, is bigger. During the night, the diameter of the stalk increases because the plant is drinking, if you will, pulling up water. And during the day, it actually perspirates. So the diameter shrinks. And so the discrepancy between maximum diameter and lower diameter is higher, but the stress wasn't enough to have huge variations. And then rainfall started, leading to a small increase in diameter. These are the results provided by the PAR sensor. We divided the results in 3 parts. April, May, June, to see the changes over time. And we can see we observed the shade between 10 and a.m. and 2 p.m. And what we realized was that about 30% of PAR, daily PAR, is observed. For the temperature, the discrepancy is similar. We can see on the graph that temperature was lower with shade provided. And on average, there's a reduction of temperature of 0.5 degree for both nets. And the maximum temperature is reduced by nearly 2 degrees for the black net and 1.68 degrees for the green net. Regarding the hydric potential measured on plants, we measured it on lavender and valerian, early season, mid-season, and heat wave. For the valerian, we realized that the hydric potential was over 3 bars. But the plants were impacted. I forgot to say that there was irrigation provided for the plants. So either the measurement system was not adapted to this plant, or this decay in the plant is due to heat more than a hydric condition. We are not sure. For the hybrid lavender, we have a better hydric potential with shade. And for mid-season, we have no significant difference. But so during the heat wave and before the heat wave, the difference is more significant. For the photosynthesis effect measured, we have 2 measurements. The maximum photochemical efficiency to see the alteration of the photosystem. Is the plant damaged or not? And so this maximum efficiency is 0.82. And we can see that there is little alteration of the photosystem under shade, or with or without shade, sorry. The real photochemical efficiency is what we measure at a T time, at a given moment. And we decided to... Maybe I will tell you more later about this. But before shading, after shading, here you have the results during shading. The valerian under the shade has a much better photosynthetic capacity than the fully sunlit valerian. And under the shade, the efficiency, photosynthetic efficiency is better. For hybrid lavender, we have similar results. Although values are close to 0.82, so the efficiency lost is not huge. In the valerian, the discrepancy was much stronger.
Now, what's the most important point? Well, the most important for lavender, this lavandun, or this hybrid lavender, is to look for a negative impact. We have shading, which is going to diminish the biomass yield, the floral biomass anyway, by 31%. For persil, it's going to be the opposite. The shading is going to allow to increase the yield by 2. And for valerian, similarly, you're going to see the increase by 2 with shading. For essential oil yield, there's not really a difference in essential oil content in the lavender, or this hybrid lavender. But with regards to the biomass, we find that there's going to be an impact of 40%. So it's negative. For valerian, it's going to be the opposite. We're going to have yield, which is going to be multiplied by 2 and not diminished by 2, even if the content is in essential oil is going to remain the same for the plants in shading and the plants who are in the full heat of the sun. Now, the composition is going to be slightly modified, but we're not going to get out of the European standards. We're using the shading. So, as a conclusion, for the microclimate, well, obviously shading is going to diminish light. It's going to by 30 to 60%, depending on the period in which you take your measurements. And this is going to allow us to diminish the temperatures and the temperature of the maximal daily temperature and the minimum daily temperature. For parsley and valerian, this could be a good thing to use shading. And for agroforestry, you could use this 𝗢𝗚𝗍𝗶𝗄 as well. It allows you to keep the plants in a cool atmosphere and improve your yield. For lavender, however, you'll use a lot in terms of yield, so perhaps it's not the solution. Even if we have noted that the plant actually seems to do better in shading than in the full heat of the sun in the long term, would that not perhaps allow us to keep crops in place longer? Maybe that's an avenue for research. So what's the outlook for us? We study a great deal within the project. We have tried also to see that if shading has a different impact, to see if the plants are, depending on the plants, if they're in water stress or not, or whether the soil is suffering, etc. We looked at the effect of shading. Is this going to be offset if the plants are suffering any kind of soil or water stress? We've also been able to measure humidity, soil humidity, water, the leaf surface temperature, obviously for the water, the foliar surface, the water, water content within the fallen leaves, etc. We've been able to do that. And we have a constant shading test ongoing for lavender. Please keep that in mind. So thank you very much. And if you have any questions or comments, please don't hesitate. Thank you very much, 𝗀𝗲𝗯𝗲𝗶. That was a wonderful demonstration of all the work that the iteipmai is doing. The results highlight the importance of this agroforestry approach to species. Now we've seen that it's not an exact science. There's still a great deal that has to be done. Now I'd like to open the mic to the floor, to the public. Hello. I have a question regarding the experiments on the lavender. I wanted to know, what age is this hybrid lavender? Is it forecast that you're going to keep them on the long term in shading to measure the impacts? No, this is the second year of production of the lavender. So this was planted in 2000 in, let me see, 2 years ago, so 2023, and this is the second year of life. And yes, we are going to keep them. We'll keep them at least until next year, and subsequently we hope to be able to continue, depending on financing, obviously. Hello, I'm from the 𝗢𝗄𝗯𝗲𝗶. I'm working on agroforestry, particularly, and the forest. So this is a question for you, but perhaps for all the other speakers who are going to follow, particularly the two who are going to follow you. In your project, I see that there's a shading test, but do we have an idea how the plants could have worked with a water which is, I suppose, letting waterfall beside the plants, if I have understood correctly? I was at a conference last week where my colleagues from the 𝗻𝗁 talked about a project, a cheese project. I don't know if it's called the cheese project. I don't know if you're aware of it. And here they were talking about the fact that there was water, it came from the tree at depth, and this is not always highlighted in research. This has a competitive effect on crops. Do you have an idea of how that might work with your research? Well, there is a second project in the project. We looked at the 𝗀𝗄𝗯 project, where I'm working on one particular action, the shading effect on crops. However, there are lots of other actions, of course, that we can look at and that we are looking at, where there are studies being done on the PARs and also the certificates. Yes, these plant variety certificates or rights, people working with crops. But there's not a specific study on the water in the soil because it's too complicated to put it in place. There were studies that I've read which show that in periods of drought there can have this effect, but not in this project.
peut-être du coup pour compléter, dans le cadre.
So just to add something, when you look at the 𝗀𝗄𝗯 project, there is something being done, something which is very similar to the study that 𝗀𝗲𝗶𝗶𝗃's working on, and it's taking place on an experimental parcel in the 𝗲𝗄 area of France. It's a very traditional, historic agroforestry R&D parcel. We have a canopy of hybrid walnut trees planted in 1906 by the INRAE in Montpellier. And underneath this canopy, depending on the R&D project that we're participating in, we plant different things. Now, traditionally, we had a great deal of market gardening, lots of vegetables, but with this opportunity, with the 𝗀𝗄𝗯 project, we've also planted basil, parsley, and valerian in rows with different. We've got shading in some places. The walnut trees have been cut back, and shading is very different depending on where they're planted. We look at the different states of the plant, and we look at the canopy, the leaf cover, to see what's happening. And we've begun to see some results with parsley and basil, not really so much with valerian, because we have to wait till next year. It was recently planted. And I talked about it very rapidly earlier. What we saw was there was a reduction in yield, but also there was an impact on phenological maturities. So perhaps we should sell on the long term. With regards water, we began to study what's happening under the trees. And we've given the plants, we've given them enough water so that we can look from an agricultural perspective. We could look at what's happening. And what we saw, that was with the agricultural control, we had twice the amount of water than we did for the plants being used where the trees had been cut back, and this had an impact on the final yield. Problem in all of this? Well, monitoring this in water means that you have to install very expensive material, and we have agricultural equipment in situ, agricultural equipment from the farm. So we need to invest in better equipment in order to study the quantity of water necessary. It's complicated as well to separate the fact of shading from the temperature, and water is going to evaporate, etc., from the other aspects that are taking place in the soil. Hello. Thank you for your presentation. 𝗀𝗃𝗃𝗏𝗃. What percentage of light is filtered? Well, I think 60% of the light gets past, 30% gets through, 30% is absorbed by the shading. It's the same for the two. It was supposed to be a 70% net and a 95% net. That's what we had with regards to guarantees. But when we took the measurements ourselves, we realized that this wasn't exactly the same amount of light that was getting through. I don't know if I've got time to explain. It depends on the type of the net or the color, but when you look at the plants and the photosynthetic systems that are the specialists themselves, so you can see that this the experiment's going to take place over several parts, the tree, right up high if the branches are very wide, the reduction as the tree slims down to its trunk, etc., and the effect in the soil. There are a lot of factors to be considered. After your project, do you know what type of essences you might be type of plants you might plant, what you might want to put in the field? No, not at all. I don't know if someone else has an idea, but no. Hello, Jean-Alfred Coudamou Group. Now, you carried out the study of the permanent shading. Can you imagine studying, perhaps just having precise shaded moments for the crop? Oh, I'm sorry, I didn't mention at the beginning. We take the nets away in winter, when the trees lose the leaves, we take the shading away and we put them back when the trees begin to bloom again. If you have permanent shading, these are tents that we built in order to have all year long shading. Well, the plants have the sun in the morning and they have them at night from up until May. And then, for example, in the summer months, they're going to have shading maybe just two hours of the day.
S'il n'y a plus de questions,
Well, if there are no more questions, I think we're going to give Amandine another warm round of applause.